Still in polynomial concepts, we have another graph, right? Notice that this graph is continuous. There are no breaks, but I am going to put in my arrows at the ends because that will help me determine what's going on. Notice on the left side, we fall. And on the right side, we rise. Okay. So is this a graph of an even or odd degree polynomial? Because the arms go opposite ways, that means that we are odd degree. If they are the same, it's even. What is the least degree of the polynomial based on the turning points? Let's go through and find the turning points so we can find the least degree. Remember, we're going to work from left to right, driving on our graph, and if we have any turns of turning the wheel to stay on the road of the graph, that'll be a turning point. So we're coming up from the infinities. We have one turn, had to turn the wheel to the right. Now we have to turn the wheel to the left. So that's 2. It's an S curve, so there are 2 changes in direction. Come up the graph. We have another turn. Crash back down to the ground. And we have yet another turn. At the 4th turn, x equal to 0. But then we have this little hiccup. There's a 5th turn here. And then yet another one. So a 6th turn because we had to go back up. And then we head off into the positive infinities. So we have 6 turning points. And our degree of our polynomial is our number of turning points plus 1, which means that we are going to have 6 plus 1, and we get n equal to 7. 7 is odd, which makes sense because we said that our polynomial is odd. So if we get a minimum degree that doesn't fall into behavior of the graph, it's even when the other is odd, or it's odd when the other's even, we know that there's some kind of disconnect somewhere. We need to review our work. Is our leading coefficient positive or negative? Our right side rises, and because we're having our positive note, our leading coefficient is going to be positive. For our zeros of the polynomial, remember that we need to go along the x-axis and find where we either cross or touch and turn. Notice these lines. It takes us 1, 2, 3, 4 lines to get to -2, which means that every 2 lines gives you a whole number. So we're going to have -1, -3, then -4, and then going to the right, we have 1, and then our 2's at the end. So if we're looking for our zeros, the first one we see is x equal to -4. Next time we touch the x-axis is at x equal to 0. And then we have another one, our last one, at x equal to 1, which means our zeros are x equal to -4, x equal to 0, and x equal to 1. Even multiplicity, remember, that means that you touch and turn or bounce. If we look at our graph, we're touching and turning or bouncing at two different x values. We touch and turn at x equal to 0 and x equal to 1 because we did not go from above the x-axis to below. We stayed above the x-axis after we touched the graph. When we are crossing at x equal to -4, we have our odd multiplicity. And we are ready to find our equation. I'm going to name our equation h of x, just because I can. We've already used p of x a couple of different times. We said we had a positive leading coefficient. I'm going to put in a 1 for a placeholder. We'll make it look nicer in a second. Our zeros with even multiplicity, we said were x equal to 0, which gets us a factor of x, and x equal to 1 gets us a factor of x minus 1. If you want to do x minus 0, you can, but you will need to clean it up. So we're going to have x minus 0 and x minus 1, but we said that they had even multiplicity, which means they are going to have an exponent of 2 each, because 2 is the first even number we know. For x equal to -4, we know his factor is x plus 4. And we're going to use that in part G. We know that he has an odd multiplicity, which means that his exponent is going to be 1 or 3. We need to figure out which one it is. Because at x equal to -4, we have turning points. Notice we had turning points 1 and 2. Right around x equal to -4, and we are crossing, that means that we are going to have a 3. So when you have turning points around your zeros, it's not going to be a 1. It's either going to be a 2 or a 3 for your exponent. And let's go ahead and make this look a little bit nicer. I'm not going to write the 1, and x minus 0 is x. So I have h of x is equal to x squared times x minus 1 squared times x plus 4 cubed. And keep in mind that you can have the parentheses in a different order, but keep that x squared out front to make it look nice and simplified.